uh, and try to mimic or try to get better performance through some learning into a student model which is much smaller. And what we were more interested in was that, again, noise distillation was not a new concept, but we were interested in looking at how can we do this in a data free manner, which means that you do not have access to any data while doing the distillation. So one way to do distillation is basically you take the logics of the teacher model, and you basically have some data that you're using to distill. You compute the logics on the teacher model and the logics on the student model, and you try to match the distribution, and basically that's how your student model learns to in some way mimic the capabilities of the teacher model. But we wanted to do it in a data free manner because often the domain of the problem you're working with, you either don't have too much data for distillation, or you just don't know what kind of data should be distilled on. So we wanted to learn that. So we basically worked on this generator, which was trying to generate optimal samples for a teacher that it could then distill down to a student. So basically there's no data, we generate data, and that entire generator is also learned end to end. So that is what we were doing, and it worked pretty well. We sort of showed it through a bunch of iterative distillation steps, and showed like multiple x improvements in speed and performance. So that was like a rough idea of like one project I was doing in bits. If that sort of helps anyone get context. Again, most of this one was with AppCare, with Professor Ashwin and Titraj, and yeah. So after that, I did my thesis, which was more on medical imaging. Again, this was interesting because medical imaging, or this project, which was universal lesion detection, is basically a 3D understanding problem, because your body or human anatomy is 3D in nature. It's not like a 2D scan. So we're basically doing a projection into 2D, but you have 3D information through multiple phases. And this was interesting to me because it was quite similar to the problems that I was exploring in videos, because most of the times videos are similar. Videos are, you can think of videos as like a stack of frames, a stack of 2D information, which is the same thing here. And the problems are quite similar in terms of there is redundancy, but there is also very meaningful information and very small phases of your data. And how do you make sense of it? How do you improve it across a large scale of problems, anatomies? How do you generalize across those anatomies? I think those were some of the challenges that I was interested in at that time. And the reason for that was that back in the day, most models for doing this universal lesion detection, or like lesion detection in general, were per anatomy. For example, different CT scans of different anatomies are quite different in nature. For example, the CT scan of a sort of chest is quite different from a pelvis, and so on. So mostly at that time, if you train one model on one kind of scan, they did not apply too well on the others. And we wanted to see how we can be more fundamental in nature, or in training those models, and see if we can basically use learnings from one kind of anatomy into another, and overall improve performance across categories. So we tried this universal lesion detector model, which uplifted performance for a lot of low performing anatomies, which was pretty cool. Um, and then after that, as I mentioned, I did an internship at CIQ, and then joined Google. So at Google Research, one of my main projects, or like research ideas, was learning from hierarchies, or learning from labeled relationships. So basically, we know that objects in the world are not independent. What that means is that a desk is related to a chair, a cat is somewhat related to a dog, which is totally unrelated from, let's say, a car or a motorboat or something. So there are these dependencies that exist, and while modeling or training any kind of classification, detection, any kind of models, we often don't take into account these relationships. There are some cases where we hope that implicitly our model learns through the large number of data if we provide it sufficiently, and if there are um, some sort of implicit signals in the data that can pick from. But generally we don't explicitly model those, and the argument was that in order to increase robustness in certain scenarios, you need that extra information, or you need that context, because we don't treat everything independently. There's a relationship between them. So effectively we were trying to see how we can reduce, or like the idea is quite simple. For things that are closer in the semantic hierarchy, we want the mistake penalty to be lesser, but when the mistakes are further away in your hierarchy or in your tree, for example, if you are mispredicting sort of cat as a dog, that's an error, but that's a lower penalty error as compared to if you mispredict a cat with, let's say, traffic cone or something, which is like really critical in self-driving applications or other applications. So basically that helped us learn through these hierarchies, increased robustness of models. We were able to learn from much lesser data, because we are sort of trying to add extra information through the knowledge of the world, and overall just had like better multi-level performance. So yeah, that's what I was, one of the projects that I was working on there. After that, I went to CMU, and was doing a couple of projects on image to 3D. So basically, there were some works which could take in images of objects and try to generate 3D, or like a mesh of 3D mesh of the object. What we were more interested in was basically we wanted to make it more personal. That is, if I take three pictures of my dog, or if I take three pictures of my bag or my bottle or any object around me, I should be able to generate a 3D object, or like a 3D mesh of it, and also control that mesh. For example, in this case, you have like three images of a dog. I wanted to generate the 3D of a dog, and then I can control it through text. Let's say I want to add a hat on top of this dog. So things like that. So you need to, that comes with a couple of challenges. One is obviously learning the 3D geometry and 3D consistency, which is hard from three or like two three images, because there is obviously missing information, so you need to generalize across that. And secondly, when you are over focusing on sort of the multi-view consistency part, you miss out on the adherence to your actual object that you were trying to generate the 3D for. For example, if I'm trying to do it for my dog, it would obviously sometimes make it a very generic dog, or like some other notion of a generic dog that it had learned in its sort of pre-trained distribution, and it would go away from trying to model certain artifacts in my dog. Let's say if there's a patch somewhere, it would not get those. So those were like the challenging aspects, and yeah, those were like the more interesting research challenges that we were trying to solve there. um, and then had a little bit of a stint at Waymo, where I was working on self-driving simulation and uh, agent trajectory prediction. So basically, what that means is that in this particular scene, if you look at the blue car, that's basically the self-driving car, and this sort of is like how things look like in self-driving, where there's one car, there's multiple agents. An agent is basically another pedestrian, cyclist, another car, and so on, and you're trying to effectively go follow your trajectory while being aware of what other agents in the scene could be doing, and basically factoring that into your predictions. For example, if there was some car coming at really high speed from the road that this car is trying to intersect into, or merge into, then you need to model and see whether that car is slowing down, whether what kind of trajectory would that car have, and then accordingly take decisions on your car. So I was working on the sort of behavior or trajectory prediction side of it. And the reason why it is challenging is because in sort of simulation, you also don't want to predict just the most possible trajectory, but you want to make the car's behavior more robust. What that means is that while you're predicting trajectories for the other agents, you want to ensure that you are factoring in a certain sense of uncertainty in their decisions. You are If you just let, or if you're too biased on, let's say, this car in this particular scenario will just be at a constant speed, just like a very naive example, while that will hold true for 99% of the cases, but that 1% where the person in the car just decides to speed up a little bit, those kind of long tail problems come up in self driving, and you want to obviously be more robust to those. So way we were doing that was through some uncertainty modeling, where we wanted to introduce some uncertainty into the intents of those other agents. And then I can't go into too much detail, but basically using that to increase robustness, and that led to quite a lot of uplift in simulation. So yeah, that was what I was doing there. And And then a little bit on the multi-view body part segmentation problem, and like the active learning side of it. So this was in like collaboration with Meta, and what we were doing there was basically, a lot of people might be aware Meta has a lot of focus on the metaverse and 3D avatars. So generally there are this dome-like setup with hundreds and 200s of cameras which are capturing people and trying to generate 3D meshes, and which are used to then train models. The issue with that is that you need labels to train models, and labeling across 200 cameras across something as dense as segmentation is almost impractical. You have to operate with very limited annotated data because you have a fixed budget to annotate the segmentation masks. And what we wanted to see was how can we minimize that. We wanted to see what kind of problems do these segmentation models or like multi-view segmentation models fail at. And one of the issues there is like on occlusions. For example, if there is some person which is doing some action like this, then in the frame of the front view, you would see that it's kind of confusing where which hand is what, if I give it this or if I give it this. But if I just turn around, you can clearly see which hand is what, and you can appropriately mark labels. So what we did there was we again used some sort of multi-view uncertainty, which basically said that we had information about the cameras of each of the, let's say, 150 n cameras, and we could get predictions of those from a very lightweight model, and then we could try to map them or cross project all of those views back into the 3D space, and then see in 3D what is the sort of uncertainty that a particular point is getting. And basically the same idea that I was just talking about, something that is ambiguous in this frame is no longer ambiguous now. So overall, if something is more uncertain across views, you mark that as a harder sample which you want to get more data for, and you keep doing this iteratively over, let's say, 10 steps, where you gather, let's say, 500 data points first, try to resolve those ambiguities, then 500 more, resolve those. Iteratively, you do this like 10 times to see much better overall results. And even if you train it with like 5,000 data points, then in the end, that the model seems to do much better than just naively training on, let's say, even 50,000 data points. So you get a lot of improvements both in terms of label efficiency and also in terms of the performance, because you're implicitly learning from, you're iteratively trying to improve your model's performance by understanding where it's bad at, using that uncertainty to guide your next stage of training. So again, that was super interesting and sort of helpful. um, and then after that, a little bit more work on sort of document understanding, synthetic data, and so on. So yeah, that's a little bit on like technical side, and hopefully that gives like some picture of what were motivations behind certain things in a technical side. um, Moving on to certain lessons that I learned along the way, I think the biggest lesson is start early and start today. I think that's important because I would have loved to start in my journey even earlier than my second year, maybe in my first year itself. And it's never too late to start. That being said, you want to start today. And by start, I mean whether you're completely new to the field, you want to sort of get some learnings. If you're just interested, you can always start. There's so many resources, and I think there's folks from Seidel now who will always be happy to help. And then if you have a little bit of exposure but you want to try out bigger, more challenging projects, again, start today for that. Try to find those ideas, try to reach out to people externally, internally, both professors at bits as well as professors outside. And yeah, just keep trying. It's a lot about resilience. You No one sort of, you'll have to pave your own path there. So just start early, start today. Project selection is also a key part. One of the things that one of my sort of very senior people at Google once told me, that it's important to keep a balance in your portfolio of projects. At one point, you want to also have certain projects that are more ambitious and long term in nature, where you don't always expect immediate outcome, but they are very important to keep your sort of scientific curiosity up, or at least keep your curiosity about something in your mind going. And at the same time, you also want to work on something that you know can give you something tangible in 6 months, because you also want to advance your career, and you want certain milestones along the way that can basically guide your next chapter. So try to maintain that. And again, It depends from person to person, and this advice might not hold true for everyone, but I found it super helpful to have both a short term and long term picture of where you want to be, and try to have your projects accordingly. Have one really hard problem or ambitious problem in your portfolio, which is like a long shot, something that could a fulfill your intellectual curiosity, and also uh, be challenging enough to be pretty impactful, and at the same time try to also optimize for your medium term incentives, whatever that may be, whether that's a PhD, masters, job market, or whatever. And surround yourself with people smarter than you. I strongly believe that you are, or at some point you become the average of your company, or by company I mean people around you. So if you're naturally spending time with people smarter than you, you're bound to get smarter, and you can just learn a lot from everyone. I think everyone comes with a diverse set of skill sets, so be open to that. Try to interact with smarter people, and I think that that'll just help you in different ways. I think there's so many amazing peers I had at bits who helped me with really small things, and I still have at the back of my mind the small lessons that I picked up from everyone. So yeah, surround yourself with smarter people. Your work relationships are important, and often the quality of your work will dictate that. What I mean by that is that whenever you're doing projects, either with your faculty at BITS or externally in your thesis, or with any internship with your managers, try to have good working relationships with them. Try to be responsive, hardworking. Try to meet your deadlines as much as possible, because at the end of the day, whenever you're looking for next opportunities, they'll be the ones that will open those for you, both in terms of letters of recommendations, in terms of referrals, in terms of just guiding you on the right path. There'll be your mentors along the way throughout. So try to acknowledge that early on. Try to not make mistakes of cutting sort of ties early, or burning bridges, or if something's not working out, be honest, have right communication, and just openly say that maybe I'm not getting time for this, this is not for me, or maybe I'll like to revisit this in the future. But as much as possible, try to be honest, try to work hard in whatever internship or things you're doing early on, because that'll open your path for the next chapter that you're looking for. And yeah, one thing that I cannot get tired of explaining: grades are very important for grad school aspirations. So wherever you are, try to push it. If you're at 7, try to push it to 8. If you're at 8, try to push it to 9. If you're at 9, try to push it to 9.5, 10. Just keep in mind that the higher, the better. At some point, obviously, you will get opportunities without grades as well, but it'll just be a little bit more easier to get opportunities right out of undergrad, because the only most of the, in most cases, the only signal that people will have externally towards you is the grades you have. And like, unless you have like really strong publications or something, which is hard. So yeah, grades are important. Please focus on that. And yeah, try to publish high quality work as early as possible. Again, as I mentioned, whatever aspirations you have after bits, two things are important: grades and also publications, if you are able to do so. One thing that I wish someone had told me back in the day was to be a little bit more courageous in terms of publications. What I mean by that is to aim bigger. I think back in the day, I did not really feel like maybe I could get like a really top A star publication. I was lacking that confidence, but I think everyone should build that up. And I know for a fact that, especially even if you look at Folks Insider now, there's a lot of people with really good papers and publications. So it is possible, and it is definitely possible if you have a little bit more will and a little bit more confidence. And I'm pretty sure most people here can get to that, but you just need to believe in that, make it an obsession. uh, just tell yourself every other day that you can basically get those levels of publications. You're no lesser than any other sort of university or student in the world, and try to keep that mindset. And if you do that, if you have the right mentors, it is possible. And I think you should push for it, set that goal for yourself, or set like high goals for yourself to be able to get them. And yeah, keep trying for better opportunities. Cold mails are super effective. Fun fact about cold mails: you generally have 5% or lesser success rate, which means that if you send 200 cold mails, you'll have like 10 replies. Out of those 10, likely 7 will be rejects and 3 will be okay, let's chat. And even in those 3, maybe one of them would be willing to help you or offer you something. and the others would just not go well. So like just understand that it's a game of scale. Like cold mails are effective, but the chances are lesser, so you need to hedge your bets accordingly. So you need to try more, you need to be resilient. Also, I don't recommend just blindly reaching out to people. When you're reaching out to people, reach out to them with a thought. People get a lot of emails on like emails, LinkedIn messages. uh, Most people don't have the time to go through all of them after some point in life. So be a little bit more thoughtful when you're sending stuff to people. When you're asking for collaborations, talk about their work, not just as a one liner that yeah, I saw your work on XYZ, but at least show the person that you've read their work. They'll be more likely to reply. Talk about what you found interesting or what you're exactly looking from them, whether that's a thesis or an internship or whatever. Mention things in detail. What dates are you looking at? Whether you want paid, unpaid. Just mention everything in detail, because if anything's ambiguous, you get an email at some point in life and you're just like, I don't have the time to respond to this, and I ask for questions, ask for follow-ups. So if you're specific about what you need and what you have and what you're offering, you'll increase your chances to get responses. And don't be afraid to ask for help. Fail faster, learn faster. As I said, that falls in line with yeah, surrounding yourself with people smarter than you. Learn from them. More often than not, if you're in the right room, you'll have a lot to learn from every person in the room. And just get a habit of doing that, because I think um, you don't want to waste time on doing like trivial things. You want to make the best use of your time, and that just comes with learning from everyone around you. And try to enjoy your work. That's probably the most important thing. Make sure what you're working on, you're passionate about it. Most practical projects, research projects, require a lot of like perseverance, patience. So if you're not interested in something, it's very likely that you won't follow up on it if results are not good. So try to pick projects that you're actually passionate about and you want to make things work. If things don't work in 3 months, you want to still have the will to continue, and that only comes when you're madly obsessed with the things that you're working on. You want to really enjoy your work, and just it should keep that mental thing going in your mind, that okay, why is this not working, how can I make it better, what could work. It should be in the back of your mind if you're something, if it's something really passionate about, and that's when you know that you want to do this for the future, or you want to pursue this as a career. So yeah, those would be some lessons learned. Next, talking about sort of industry impact and research in industry. I think now there's a lot of opportunities in research and industry, and some would argue that there's more opportunities for research and industry with compute being so important in the field. So again, three types. Most of this is probably known to everyone. There's three kinds of general work that I've seen around in industry. One of them is next frontier research, which is basically doing things with the notion in mind that what could work maybe 2 years, 5 years from now. Things that don't necessarily work now, but are more experimental in nature, that are higher uncertainty, more likely that projects won't work, won't have results for 6 months, 8 months, but you keep trying. You sort of keep pursuing those ideas because they have some either intuitive sort of backing behind them, or some theoretical evidence that this could work. So those are riskier bets. That happens. There are a lot of projects like that. Then there's advancing current capabilities. Basically, there's a sufficient scope of exploration left, but you're still not certain on how to get there. But you know that if you keep iterating on it, you see a clear goal, but it's how to get to that goal is not clear. And I think there's a lot of projects and like work out there as well, where something could work in maybe a year or two, but you just need to figure out the right investment in terms of people and also time into the problem, and you could get somewhere close to it if things work out. And then there's like more product driven research, where some things work as research ideas, but they don't work at the scale you would want to launch products at. So those come with different set of challenges, where we're thinking about how do we make this thing work at scale, how do we sort of wrinkle like remove out the minor wrinkles in the way, and so on. So there's scope for all kinds of projects from what I've seen in industry. There's especially at DeepMind, there's projects on all three themes. So which one, I think it just depends on your interests. where you want to be in your research career, or overall in just your career. What kind of projects drive you better, are like what kind of challenges. Each of them come with different levels of challenges and uncertainty, and it depends on person to person on what they enjoy the most. And yeah, the good thing, as I mentioned, is that you generally get opportunities to work on diverse projects. You If you're interested in something, you can obviously pursue that particular direction if you're good enough. So the keyword is if you're good enough, and for that, it's that part is just generally up to you. No one can do that for you. You have to build your own skill set. And yeah, some more key takeaways from like my time overall, and like so far, the journey that I've had is aim bigger. I cannot stress this more. Set ambitious goals for yourself, and strive for excellence. And that may come off as a cliche, but I think it's super important. You want to think as ambitious as you can. And one thing that I like to think of, or like a mental model that like to follow, is that if something seems achievable in your mind, then maybe you're not thinking higher enough. You want to think that if at some point you're thinking that, okay, maybe in I don't know, 3 months I can get to this level or something. I think maybe then you're not thinking higher enough, or not setting ambitious enough goals for yourself. At every point, whenever you're setting a goal, you should have it with the mind that, or mindset that, yeah, I don't know how I'm going to get there, but I'm going to push as much as possible. And that level of push will take you, or will give you that extra edge um, over others, and like in general will just push you to get better and better, and just self improve, which I think is like probably a very very important trait. So have that confidence in yourself, have the belief to set those ambitious goals, meet the right people, and try to achieve those goals. Is like a very simple one liner there. Again, as I mentioned, surround yourself with like-minded ambitious individuals. Keep trying. Most projects won't work off the shelf in a few months. You'd need persistence across months. Feedback is key. Keep learning, keep asking. Ask your mentors for feedback every few months, whether that's your internship hosts or professors. Ask them what you can do better. How would they approach certain things? Just keep learning. Keep on the lookout of what other things you can learn and improve on. A lot depends on luck. Honestly, a lot of opportunities you'll get are just out of luck. Sometimes you'll feel unlucky. Sometimes you'll feel hard luck, like not well done by you. Think some things are favoring other people. Just a lot of those things are not in your hands. But the good thing in your hands is you can make your own luck. There's a common saying that if the door does not open, you can always break the door down. And in this case, if, as I mentioned, the most important thing is if you're good enough for something, no one will stop you. No one will be able to stop you. If you're good enough in a particular skill set, you will not have trouble finding opportunities. You will eventually get them, even if it's harder in the beginning. If you're good enough, you'll find your way. And yeah, keep doing projects. I think now with so much resources available online, it's easy to get bogged down looking through papers, looking through blogs, looking through video tutorials, courses, and everything. At the end of the day, what will give you the best picture of where you stand and what issues you're facing and what you find challenging is projects. Even if it's like a smaller project, which is like an implementation based project, if it's like a research project, which is much more ambiguous in nature, attempt those. You'll get a better picture of where you are and where you want to be. So yeah, that's probably brings me to the end of this talk. Thank you everyone for listening for the past 40 minutes I've been talking. And I've attached some social links here. Feel free to connect, reach out, ask if you have any follow-up questions, and I'll be happy to help as much as possible.
Yeah, so like let's start with the questions. Or someone raised their hand, they could go ahead.
I think you might need to unmute them. Like, I think they might be on mute by default. Or if can the person post in the chat, we'll just say.
Yeah. Oh,
Okay, I think I'm just going to. Probably that was a mistake, I guess.
okay. Probably the emoji icon, if you want to try, is on the other button, not that one, guys. Um, okay, so we had some questions before the talk which we had collected before. One thing was like, how did you exactly like start like learning about what coursework you did? How did you go about it? Did you have
Yeah.
some a lot of coding experience or just theoretical experience? Like, how was that?
Yeah, I think again, so I started with Seidel. That was I think in our batch, I think 7 or 8 of us joined. Before that, there were like 3 people in Seidel, so it was pretty early. But I think Seidel was super helpful. I strongly remember the impact each and every member of Seidel has had on me. So it was that early. I've learned so much from everyone there. So there was this interesting assignment, Seidel assignment in the summer of I think first year, which was like a great resource for me because it gave me an idea of like different kinds of domains when it comes to vision, language, RL, uh, even like just ambiguous combinations of them, ambiguous like wider problems. So I think that was a good starting point. After that, I followed up with online courses back in the day. Like a couple of Coursera courses were probably the best resource you could find, but now I think there's a lot better resources available. Depends on your area of interest. Try to Google. There's so many amazing blog posts. There's a beautiful blog post series by Lilian Wang from OpenAI. There's also a really good blog post by Noah. Uh, and Yeah, there's a few good resources out there. I think you should not have trouble finding those. Then obviously there's coursework. I think coursework is important because you're formally learning something, and I think when you're formally learning something, you are in general constrained to learn it in some level of detail because you're generally under the threat of will this be asked in an exam. And you at least I don't know, back in the day I used to be a little bit more on the lookout into the fine print and like details, think that okay, maybe like this particular piece of theory or equation, I need to fully understand it, because if I don't understand it, like I won't get anything in the exam. So I think that's also important to some extent. So it's a combination of both. I think earlier during my time we had like ML and NFL courses. I think there should be equivalent or more courses now. Try to take those, try to do online courses, online resources, and try to do mini projects. There's Stanford 231N, which is pretty helpful, 2 to 4, which was pretty helpful. So look at those courses, those are super important. Do their assignments. I think that those are like pretty good resources to get started. And then once you develop interest into something particular, you can start reading papers for those, and you'll naturally get an idea of what kind of work you want to do.
Thanks a lot for that answer. If anyone else has any questions, feel free to put up in chat or unmute yourselves. Otherwise, we can take up the other questions also. Okay. Second question was basically like, once you like start doing courses, once you like start doing stuff, like doing some hands-on projects, like dummy projects and stuff, how do you reach out to pros? Like, how do you reach out to pros on campus? How do you reach out to pros externally? How does remote work go on? Like, what's your
Yeah.
experience been and what would you suggest?
Sure. So I think I'll answer those step by step. So I think when it comes to approaching people on profs, like profs on campus, I think the best way is try to find who are currently working with the prof. Try to talk to them, gauge their experiences, what kind of problems they're working on, if they're interesting to you. Try to talk to them about their project details. Try to read a bit more about them, and then go to the professor talking about, I spoke to this particular senior or lab mate of yours, and got this idea of your projects. I'm interested in this. I've done this reading. I know a little bit about this. I have like little experience doing a mini project or doing something like this, and this is the time commitment I can give. And you can either do that informally or formally in like an SOP, but like informally also, the only thing that professors look for is time commitment. So if you are able to say that I'm willing to make this commitment, then I think they won't disagree. So they have like a fixed number of people they want to work with, because after a point advising too many people becomes really hard. So you have to show the desire and willingness that you can do this work, and this is, you will be committed to it. So I think those are two signals that they will look for, and it depends on you on how you can convey those signals. When it comes to externally, I think, as I mentioned, cold mails are effective, but the probability game is like pretty less. So it's about scale. You have to try more to get opportunities. I sometimes I've heard from like some people that they said that, oh, we mailed 50 people but did not get any responses. Let me say 50 is a very small number. You need to increase that, and by that I don't mean blindly mail people. As I mentioned, keep it detailed to a sufficient degree where they would be interested to read your response, read your email. So have that in mind. Don't just blindly email people with the same template. Everyone knows. Like it's like, think of it from your shoes. If someone sends you an email which looks very templated, like you can very easily see that it is a template which has replaced maybe like Professor Word and Project Word and something, and everything else is the same. You won't reply. You won't waste your time on it. You'll be just like, this person has sent it to 100 people. Whereas on the other end, if you read like a slightly more personal email, even though you know that this email has gone to 50 other people, you would at least appreciate that the person took the time to read through your work or read through something that you're doing, and is actually interested in that particular thing. And again, as I mentioned, just changing project name in emails doesn't do anything. Everyone can read through that. If you're talking about something in detail, about something that you found interesting, and like why. um, and I think when it comes to remote work, I think that's a good opportunity, being in bits, to do work. As I mentioned, I often did multiple internships even in one summer, also multiple internships while being in campus, and those were remote. So I think remote work is good now. Try to leverage it, try to see, but also be capped on your commitments, because as I mentioned, whatever work you're doing, make sure you can commit to it. Don't sign up for 4 internships and like do neither of them well. So I recommend just do one or two projects, whether that's with prof or external profs or internships, but not more than two projects at a time. And be fully aware of those, what kind of course load you're signing up for. So try to have that balance, on, if you know that you're going to have bad course load in a particular semester, maybe balance your project portfolio accordingly, where you like, I'm going to do only one project this semester to compensate for everything. But I think you should be able to balance that up.
Chirag posted a question in the chat. He's basically asking about how do you just get into NLP and AI roles, and like for dual specifically, if you have any advice that whether they should pursue a thesis or whether they should go for the data science roles, which companies come for DPS.
Yeah, I think I think it depends. The job market will always be open for, I think, niche skill sets. The generic skill sets are, I think, could be questionable. But if you're if you have a particular niche, and you have a skill set that is n- not very common, you will always get opportunities. By that I mean, if you're like thinking about like NLP, if you're just like doing some projects on like text classification or something, that's not like really a niche. If you're doing something deeper, if you're doing like, by no means like, if you're doing text classification but you're doing it through some lens of like really making overall, the domain more generalizable, or whatever. So there needs to be some particular niche that makes you stand out from the rest of the crowd. So if you're picking up projects that are challenging enough that can give you that skill set or that niche experience, I think you will always get opportunities. But if you're doing projects that are just built off some implementations or minor incremental work, that I think might not be the best way to do things. And when it comes to thesis versus PS, I'm not sure about PS because I did not do a PS, but I think thesis is helpful, generally, because it puts you in a position where you have to really struggle and you have to work through your ideas. There'll be guidance, but you'll have to figure a lot of things out yourself. And I think that's good, because that'll give you context on how research works, what you're interested in. That'll help you build those new skill sets. Hopefully, if you're able to land up a paper or something that can help you if you want to go further in grad school. So I did thesis and I would recommend thesis, but I don't know the other side of the picture to say that do one over the other. So yeah.
Chirag, if you have any followers, please post it. All right. So next question is basically about getting these internships that you entered at Waymo in Bits when you were at Bits, you also entered at Commerce IQ, and also you have this Harvard Medical School. Like, how do you like secure these like company internships specifically? Because from like at least this like the startup thing is like this still go for very selected few people. So how do you stand out to them? Like, do you reach out to or do you use your referrals connections? Like, what is the best way
Yeah.
to go about this?
Yeah, I think everything, mix of everything. The most important thing is the like perseverance and hard work there. And I know that's a very cliched line to say, but the more you apply and the better quality of your applications, you will have those opportunities. So if you're thinking you're applying to 40 places and not getting responses, again, as I said, increase those numbers. You have to, especially now that things are so competitive, it is hard, and I understand that, but you have to keep trying for more places. And it's like a stepping stone. You'll have one opportunity, you'll have an opportunity to do well in that, and how well you do in that will sort of dictate what your next opportunity looks like. So instead of like thinking of it like how did you land this particular internship or this particular role, I would think of as what is something that you can get started with, whatever internship or role that may be. Try to do really really well in that, and then that will enable you for the next one, because either you will learn some skill set out of it that is helpful in your next journey, or it will basically help you build connections with certain people that can help you in your next journey. So it's always like an incremental learning process. And I think it happens stepwise. It's easy to sometimes just look too far out and be like, okay, that's really hard. But if you like just break it down one step at a time, I think that will more or less keep you towards your goal, and let you get there.
Thanks a lot. Uh, One more question about this is like grad school applications. When do you decide is the right time to like pursue a master's? Do you think you should work for a few years and then go for a master's? And like second question, just to like what are the things like admission committees and like master schools look for when they are just taking in students for grad school? If you have experience with like other programs as well, like MSCS or something like that. So,
Yeah, so I think the first part of the question, if I understand, was, could you repeat the first part again?
just basically grad school. How do you decide like whether you want to pursue a master's or PhD, or do you want
Yeah,
to just work
so I
in?
think that's a personal preference sometimes. Although my recommendation would be to do things early. Whether you're applying for a master's or PhD, apply it early. Apply it out of undergrad. There's no problem. There's a misconception that you need work experience to get to masters. Some programs need that, so you need to do your research on what programs you're interested in. Uh, some programs have a little bit of requirement for people in work experience. You can get an idea of that through LinkedIn. Try to see what programs certain people have been, try to see their level of experience before going into the program, so you'll get an understanding of, okay, maybe this program historically has taken like 70% of the people with 2 years of experience. So obviously you'll have to hedge your bets accordingly. And at the same time, as I said, I would recommend, if you're sure on you want whether you want to do a master's or a PhD, apply early, apply right out of undergrad. Even PhDs, apply right out of undergrad. I think in the longer run, that's helpful, to be able to you know finish your PhD or masters early in your career. That opens up a lot more possibilities, I think. Because whether you work for 2 years and go for your masters or PhD, or whether you directly go, at the end of the day, you will sort of end up with the same level of responsibility when you start in your job, or when you're starting in, like, let's say, doing a postdoc and starting as a professor. So you'll start at the same level as when you directly go out of undergrad, or when you work for 2 years and then go, more often than not. So yeah, that's why I would recommend, if you're interested in that, do it early, do it before. When it comes to what kind of signals that grad school applications look for, as I said, two most important things. One is CGPA. Second is the recommendations, your letter of recommendation. I don't think your SOPs play that much of a significant role. In some programs they do, but most cases, the two biggest signals are your letters of recommendation and your grades. So try to have as high grades as possible. As I said, try to keep it above. Uh, I would say aim as high as possible. I won't give you a number. Uh, someone gave me a number back in the day and I fixated to that number, and I regret it a little bit. So I will not give you a number. I would say aim for 10 and see wherever you go. If you aim for 10 and get to 9, good enough. If you aim for 10 and get 7, okay, it is what it is. So aim for 10 every semester and see. Be strategic about it. That's something that I would say. Sometimes 10 is like unrealistic target because you are working on two projects and you know that these two projects are important, and you can just be a strategic, like you can be a bit more strategic about it after midsems. You know what courses you are doing good at, what you're not doing good at, and like you can just figure out how you need to optimize for that. So again, grades are super important. Please pay attention to those, because out of undergrad, that's probably your biggest indicator for anyone outside. And your letters of recommendation, try to have strong ones. Try to have good relationships with your professors at bits and outside, because if you have good relationships, they'll personally want to write letters for you instead of asking you for a template. When they're personally writing, they can write very strong points. Like I think the biggest indicator in an LOR is a comparison with, let's say, previous students that they've uh, sort of guided and mentored. Where do you stand? And if they say that maybe you stand in top 1% or top 10 or top 5 among, let's say, 100 students that are maintained or like managed, that's probably the best indicator for anyone. And that's like, just think about it intuitively. Like if I'm working with someone here and I tell in a referral that, this is probably the top 5% I've worked with, that holds a lot of value than just saying that, okay, this person is really good and I worked with them. That gives me like very subjective signal. But if I just say something like, yeah, top 5% I've worked with, that's like really strong indication of, okay, wow, this person is really up to the mark and can get that. So that will only happen if you have a really good relationship with your advisors. So I can't stress that enough. Always try to talk to them, put it in their mind early that this is what your aspirations are, this is what you want to be doing, and yeah, communicate well with them. So
If anyone has any questions, again, please feel in chat. I think it's just like 5 10 minutes left, so we can't take a lot of questions. So please put up any questions if you have. Meanwhile, another question which was there was like, how's your experience being between doing academic research versus industry research? Like, how
yeah,
they differ?
yeah, things have changed a lot over the past few years. It's been a very fast-paced field in general. I think there's pros and cons to doing both. In some sense, I think there's a little bit more freedom you get in academic research, where um, there's pressure, but there's generally more room for exploration for something or particular niche that you're interested in. Whereas in industry, it's generally always governed by what there's some bigger picture in mind, whether that's like some sort of relation to some product or something. So you're always thinking about research in terms of getting to some milestone. So there's like differences there. Depends, again, as I said, depends on the kind of person you are and what kind of environment do you prefer. An academic environment gives you a lot more flexibility and room for exploration, but that can sometimes not be optimal also, because if you're someone who just does not like too much chaos, that's probably not the best environment. And then if you're someone who likes a little bit of chaos, but you want to do research, but at the same time have some sort of goal in mind, or product goal, or like, I wouldn't say product goal, but like just some goal of where you want this work to impact, I think industry is a pretty good place as well. So it just depends on person to person. And as I said, in either of the cases, you'll have opportunities to do both. Most of the times when you're working on academic projects or on academia, your professors or your labs will have collaborations with industry, and you'll be working on some sort of industrial project, or like collaborating on something. And so you'll have a mix of both. Even when, as I mentioned, when you're in industry, you have projects that are more very exploratory and like ambitious in nature. So it's about what you're interested in, finding those opportunities and just being good enough to get them.
Also, one more question: how relevant or like important is a PhD for targeting industry research roles? What's your experience with that?
Yeah, I think yeah, it's super important. I think PhDs. Um, I think the reason you would want to do PhD is a to fulfill your intellectual curiosity. I don't think doing a PhD just to get a job is the best way to look at it. PhD is a big commitment. So if you want to do it, you'll have some signal in your mind that I want to do a PhD for this reason. And if you have that reason in your mind, then you should not think about whether this will give me a job or no, but do a PhD because you want to. And I'm pretty sure if you're doing a good PhD, you'll have no problem in finding a job. The converse of that is, if you don't do a PhD, how will your prospects be to find like a research role? Again, that depends. In some cases, I would say it's harder to find those, and it might get harder in the future given how the field is going, and how a lot of things are sort of starting to get automated. So that might get lesser. But as I've said throughout, if you're good enough in a particular skill set, you will find those opportunities. So you have to make that decision for yourself whether you want to be in pure research. I would say try to get a PhD, but even if you don't want to get a PhD, there will be no one stopping you from getting a role that is good for you if you are good enough. So there's two sides to that.
Um, a follow up on that. So, do you think the parameters you described is like uniform through the industry, or is it easier to land these roles at a startup that's coming out compared to a like obviously
Please,
Google DeepMind or something?
can you just actually let me also join from my phone. My laptop is on 1%. It might die.
Okay, yeah, sure.
Let me just give me 1 second. Yes. Yeah. So could you repeat your question?
Yeah, so basically what I was saying is the trend uniform through like the industry? So will it be as tough to say get a research based role in a startup also? You-
Yeah, I think it's the same. It's probably just a game of like demand and supply. There's a lot more people who have come into the field of AI in the past few years, and it's really hard to keep up with that supply in some sense, because the demand for people reduces with more automation coming in, and b, as I said, like if you have a niche enough skill set, you should not have an issue. But to develop those niches is also much harder because there's more competition. So it's like a loop in some sense. So I would say it's still hard to have like pure research roles without a PhD. But yeah.
Sure. Okay. I don't think we have more questions. Okay, so thank you so much, Ashwin, for agreeing to have this talk. I hope this was like useful for everyone in this what in this talk. Oh, Chirag has a question. Yeah, Chirag, go
Yeah.
ahead.
Yeah, go ahead.
You can unmute yourself if you want. That's fine.
Hello. Yeah, just I wanted to ask, like, how do you see NLP going in like next 2 or 3 years? Like,
Yeah, I think there's a lot of scope. I think there's a lot of scope in like most things. Things will get better, but when things get better, there will also be some more things which will open up some more challenges that you don't foresee today that will become a challenge tomorrow. For example, I don't know, let's say a year down the line, the kind of problems that would be in research now in an NLP would are like very different to what they are today, because the field has advanced so much in a year that certain capabilities which you would think of, okay, maybe they're not possible, start becoming possible, and then you start looking into those. So I think it's like a iterative process. Your capabilities increase, your challenges also increase after that. So I think there will be scope for interesting work always. It's just like what you're interested in, and as I said, like if you're interested in a particular thing, you should not worry too much about how what's the scope in that particular area be. Try to fulfill your curiosity. If you're interested in something, you'll naturally do better and good work, and that'll be fine. You'll be more happy with yourself with that way.
Chirag, if you have any follow-ups. Oh, yes, left. Okay. Yes, some
And like to add
follow-ups.
to that, technically, I think even if you look at language, there's still so many challenges in like NLP. Like like if anyone tomorrow comes and tells me that there's this new model that solves everything, you would still ask the question, okay, can it solve it 10 times faster? Like if there's like some reasoning model tomorrow that comes out and basically solves every PhD question or like really hard questions, you'd want to ask, okay, this works, it takes like maybe, I don't know, 1,000 model calls, can you make it like 5 model calls? So there'll always be those challenges, and when there's 5 model calls, you'll ask like, I don't know, can you make 5 different of those do some unified global task which is harder? And like it'll keep happening. They'll like I think we're still away from the time where there'll be no problem to solve. That might come someday, but I think there's still time for that.
One more question that I have, like, what do you think? Like, is it better to train a like very huge model to like do everything, or use small models to like do small tasks and have a like manager kind of architecture, basically like a multi-model AI agent for doing some task? Like, which one will be better for this?
I think in the longer run, unified global models are better. Personal opinion, might not be true, but I think the way I like to think about is you want to you have certain tasks, you have different sets of data, you have different types of data modalities. They have some relationships, and you want to leverage those dependencies. The world is not unimodal, so you don't want to model it unimodally. Also, different kinds of data have different properties about them, and you want to make sure you're generalizable across. So if you're doing one kind of task, one kind of modality, one kind of model, very niche domain, it might work for that, but it won't be generalizable to the extreme cases. And I think the good way to do that is like you can always there's room for both in some sense. Like you have smaller specialized models, you can obviously train those which are slightly easier to train. You can leverage those learnings of that small model, and in some sense use those, I would say, outputs, use those, I don't know, in what I say, those representations, and you can use those to improve on your larger model. So at the end of the day, think of it as like there's 2 pillars, and one of them is like the slower, smaller model pillar, which is easier to grow and like easier to maintain. You get that, you improve your performance on a particular domain, and then you take those learnings, you whatever that can be through distillation, whether that can be through some sort of hard soft distillation, whether that can be directly through generating more data, more supervised data through the smaller model as some guidance, and then you can plumb that everything into your bigger model. So the hope is that the bigger model has more sort of degrees of freedom in some sense to be able to learn more complex representations. So everything that a smaller model can learn, a bigger model should be able to learn. So if you're able to make a small model learn something, it overall naturally extends to a bigger model. And in the end, you would want, the hope is that something that 10 small models can do, one big model can do all of them and slightly better, because it's learning from, in general, more diverse cases. So
And I think like I've come to the end of the talk. It's almost 10:45. Thank you everyone for joining. Our next talk is at 2 o'clock when Professor Aditya Challa will talk about his research at APCA. And thanks a lot, Ashwin, for joining. It was really pleasant and wonderful to have you.
yeah, no problem. Thanks everyone for having me, and thanks for listening through my time.
Bye-bye.
All right. Yeah. Thanks.